What is an AI model? A great place to start this lesson is with AI models. They're the core of any AI system, responsible for making decisions, predictions, and even generating creative content. Think of an AI model as a sophisticated recipe. It takes in data as ingredients, processes it using a set of instructions, algorithms, and produces a specific output, like a prediction or a piece of writing. We'll explore the different types of models, how they're trained, and how to choose the right one for the right job. Understanding AI models is key to unlocking the power of generative artificial intelligence. Let's dive deeper into AI models, specifically in the context of generative AI. At their core, these models are complex mathematical structures that learn to represent real-world processes. Imagine teaching a computer to paint. You wouldn't just give it explicit instructions for every brushstroke, but rather show it countless examples of paintings. Similarly, an AI model is trained on vast amounts of data, text, images, music, learning to identify underlying patterns and relationships. This allows it to not only make predictions, but to also generate entirely new content, like writing a poem or composing a song. This learning process relies on adjusting internal parameters, which are essentially numerical values to control the model's behavior. Think of them as knobs and dials of the model, fine-tuned during the training process to optimize its ability to generate realistic and coherent outputs. The more parameters a model has, the more nuanced its understanding of the data can become, potentially leading to more sophisticated outputs. However, this complexity comes at a cost. Larger models require significantly more computational resources to train. A critical aspect of training generative AI models is the data itself. The adage, garbage in, garbage out, holds true here. If a model is trained on biased or low quality data, its output will likely reflect these flaws. Furthermore, there are ethical concerns surrounding the use of copyrighted or stolen data for training. Using such data without permission raises legal and ethical concerns about ownership and fair use, potentially leading to disputes and hindering the responsible development of generative AI. Ideally, models should be trained on ethically sourced, diverse, and representative datasets to ensure fairness, accuracy, and respect for intellectual property. Foundation models. Foundation models represent a significant leap in the evolution of AI. Unlike traditional models trained for specific tasks, foundation models are pre-trained on massive, diverse datasets, often encompassing text, images, code, and more. This broad training allows them to develop a comprehensive understanding of the underlying structure and patterns within data, making them an incredibly versatile tool. Think of them as a general-purpose Swiss Army knife for AI, capable of being adapted to a wide range of downstream applications. One of the key characteristics of foundation models is their sheer scale. They typically boast billions, even trillions of parameters, enabling them to capture intricate relationships and nuances in the data. This massive scale, combined with the diversity of their training data, allows them to perform tasks they weren't explicitly trained for. This is known as zero-shot or few-shot training. For instance, a foundation model trained primarily on text might be able to generate images or translate languages with minimal additional training. This adaptability stems from the foundational knowledge they acquire during pre-training. Instead of learning to solve a single problem, they learn general representations and patterns that could be applied across different domains. This is like learning fundamental principles in physics or mathematics, which then can be used to solve a variety of specific problems in engineering or science. Once pre-trained, these models can be fine-tuned for specific tasks with relatively smaller datasets, significantly reducing the time and resources required for traditional model training. Open source versus closed source models. While foundation models offer incredible potential, their development and deployment raise important questions about accessibility and control. This leads us to a critical distinction: open source versus closed source models. Closed source models, often developed by large tech companies, are proprietary and their inner workings remain hidden. Users can interact with them via APIs, but the underlying code and training data are not publicly available. This lack of transparency can make it difficult to understand how these models arrive at their decisions, raising concerns about potential biases and limitations. Furthermore, reliance on closed source models can create dependencies on specific providers, limiting flexibility and potentially hindering innovation. In contrast, open source models democratize access to AI by making their code and often their training data publicly available. This transparency allows researchers and developers to inspect, modify, and redistribute the models, fostering collaboration and accelerating innovation. Open source models empower a wider community to contribute to AI development, potentially leading to more robust, reliable, and unbiased systems. Furthermore, they offer greater flexibility and control, allowing users to adapt models to their specific needs and deploy them on their own infrastructure. However, open sourcing also presents challenges, including the potential for misuse, the need for community support and maintenance, and ensuring the responsible use of publicly available models. The choice between open and closed models involves trade-offs between control, transparency, accessibility, and the potential for collaboration and innovation. It's a critical decision that shapes the future development and application of AI. Popular AI models. Let's take a closer look into the specific offerings and strengths of each of the prominent AI providers. First, OpenAI. Beyond its well-known GPT models for text generation, OpenAI also provides models for code generation, image generation, speech recognition, and fine-tuning capabilities to adapt models to specific tasks. Their API offers easy access to these models, making them widely used in various applications. However, OpenAI primarily operates under a closed-source model, limiting access to the underlying model architecture and training data. Google's AI, Gemini. Gemini represents Google's unified AI platform, integrate advanced language models with multimodal capabilities. It can process and generate text, images, audio, and video, making it a powerful tool for diverse applications. Google leverages its vast data and computational resources to train Gemini, potentially giving it an edge in terms of scale and performance. Access to Gemini is provided through various channels, including cloud APIs and specialized hardware like TPUs, tensor processing units. Anthropic. With a strong emphasis on AI safety, Anthropic develops models like Claude, designed to be more helpful, harmless, and honest. They employ techniques like constitutional AI to train models with ethical guidelines, aiming to mitigate biases and harmful outputs. While some of their models are available through APIs, Anthropic also conducts extensive research on AI safety and publishes its findings to contribute to the broader AI community. DeepSeek. DeepSeek stands out as one of China's leading AI model providers, leveraging China's vast data and growing technological prowess. DeepSeek focuses on develop high-performance models optimized for efficiency and scalability. Their expertise in areas like computer vision and natural language processing has positioned them as a key player in the Chinese AI market, catering to a wide range of applications across various industries. Furthermore, their emphasis on edge computing aligns with the growing demand for AI capabilities in resource-constrained environments. Mistral AI. Mistral AI is a French company that has rapidly emerged as a leading force in Europe's AI landscape. They champion an open source approach to AI development, making their powerful language models publicly available. This commitment to transparency and community collaboration has garnered significant attention and support within Europe, positioning them as a counterpart to the predominantly closed source models offered by some larger US-based companies. Mistral's AI focus on open source access aims to democratize AI technology and foster a more inclusive and collaborative AI ecosystem within Europe. We can't discuss the leading players in the AI model landscape without mentioning Llama, developed by Meta. Llama is the large language model designed to be versatile and adaptable to a variety of tasks, much like other foundation models we've discussed. However, Meta has taken a different approach with Llama, focusing on open innovation and accessibility. While not fully open source in the same way as Mistral's AI models, Llama's code and model weights are available for research and commercial use under a specific license. This allows researchers and developers to access and modify the model, fostering transparency and greater customization. This approach differs from the closed source models offered by companies like OpenAI, striking a balance between protecting intellectual property and encouraging wider community involvement. Llama's availability has significantly impacted the AI community, sparking innovation and accelerating the development of new applications based on large language models. Its accessibility has lowered the barrier to entry for researchers and developers, particularly those outside of big tech companies, allowing them to contribute to and benefit from advancements in AI. By making Llama available under a more permissive license, Meta aims to foster a more open and collaborative AI ecosystem, driving progress and ensuring that the benefits of AI are more widely shared. Including Llama in our discussion provides a more complete picture of the diverse approaches to AI development and accessibility within the current landscape. It highlights the growing importance of open innovation and the role it plays in shaping the future of AI. By understanding these nuanced differences and specialized offerings, you can make a more informed decision about which provider and model best aligns with your specific project requirements, resource constraints, and ethical considerations. The dynamic landscape of AI continues to evolve, so staying informed about these key players is crucial for leveraging the latest advancements and maximizing the potential of AI in your endeavors. Model types. Within the realm of generative AI, various models cater to different types of data and tasks. Let's break down some key categories. Text models. These models are designed to process and generate text. They are the foundation of applications like chatbots, language translation tools, content generation platforms, and code assistants. Large language models, LLMs, like GPT, Llama, and Gemini fall in this category. They excel at understanding and generating human-like text, enabling them to perform tasks like summarizing articles, writing stories, answering questions, and even translating between languages. Image models. These models work with visual data, generating and manipulating images. Models like DALL-E 2, Stable Diffusion, and Midjourney can create realistic and imaginative images from text descriptions, enhance existing images, and even generate variations of a given image. They are used in applications like graphic design, advertising, and entertainment. Vision models. While often used interchangeably with image models, vision models encompass a broader range of tasks beyond image generation. They can analyze images and videos to understand their content, identify objects, recognize faces, and even track movement. These models power applications like self-driving cars, medical diagnosis tools, and security systems. They may leverage techniques like convolutional neural networks, CNNs, to extract features and patterns from visual data. Multimodal models. These represent the cutting edge of generative AI, combining capabilities across different data types. Gemini, for instance, is a multimodal model capable of processing and generating text, images, audio, and video. This allows for more complex and nuanced interactions, enabling applications that can understand and respond to a wider range of inputs. For example, a multimodal model can generate a video with a corresponding soundtrack based on a text description. Audio models, focusing specifically on audio data. These models can generate music, transcribe speech, and even clone voices. They are using applications like music composition, podcast editing, and virtual assistants. Models like Jukebox and MuseNet demonstrate the potential of AI to create original and compelling audio content. Understanding these different types of generative AI models is crucial for choosing the right tools for your specific needs. Whether you're working with text, images, audio, video, or a combination thereof, selecting the appropriate model is essential for maximizing the effectiveness and efficiency of your AI-powered applications. The ongoing development and refinement of those models continue to expand the possibilities of generative AI, opening up new frontiers for creativity and innovation across various domains. Pre-training versus post-training. Building upon the concepts of foundation models and their open and closed nature, let's dive into the crucial stages of their development, pre-training and post-training. Think of pre-training as laying the foundation for a building. This phase involves exposing the model to massive amounts of raw data, allowing it to learn general patterns and representations. It's like teaching a child the alphabet and basic grammar before they learn to write essays. This foundational knowledge, acquired through unsupervised learning, enables the model to understand the structure of the language, relationships between concepts, and other foundational elements. Post-training, on the other hand, is akin to specializing in a particular field after completing a general education. It involves fine-tuning the pre-trained model on a specific task or dataset, refining its abilities for a particular application. This is often done through supervised learning, where the model is provided with labeled data and learns to map inputs to desired outputs. For example, a pre-trained language model could be post-trained on medical text to specialize in understanding and summarizing medical information. This targeted training allows the model to leverage its foundational knowledge to excel in a specific domain, much like a doctor applying their general medical knowledge to specialize in cardiology. The combination of pre-training and post-training enables the efficient development of powerful AI models capable of tackling a diverse range of complex tasks. While pre-training lays the groundwork and post-training refines the model for specific tasks, often performed by specialized developers, the rise of accessible AI platforms now empowers you, the end user, to further customize these powerful tools through fine-tuning. Imagine having a versatile robot capable of many tasks, but you need it to perform a specific function in your unique environment. Fine-tuning allows you to do just that, adapting a pre-trained model to your particular needs and data without requiring extensive technical expertise. Instead of starting from scratch, you can leverage the vast knowledge already embedded in a pre-trained model and tailor it with smaller, focused datasets relevant to your task. This allows for quicker and more efficient model development, even with limited resources. Think of it as personalizing a pre-made garment. You're not sewing the entire outfit from scratch, just adjusting it to fit perfectly. This process allows you to leverage the power of large language models, for instance, to create a chatbot specifically tailored to your company's customer service needs, or a content generator that perfectly aligns with your brand's voice and style. Fine-tuning puts the power of advanced AI directly in your hands, enabling customization and unlocking a world of possibilities. GPU and CPU. Creating foundational models with their billions or even trillions of parameters requires immense computational power. This is where GPUs, or graphics processing units, come into play. Initially designed for rendering complex graphics for video games, GPUs excel at parallel processing, performing many calculations simultaneously. This capability makes them ideally suited for the massive matrix multiplications and other mathematical operations that underpin deep learning, the technology driving foundational models. Think of CPUs, or central processing units, as general purpose processors capable of handling a variety of tasks at one time, like a skilled chef preparing a multi-course meal sequentially. GPUs, on the other hand, are like a team of cooks working in parallel, each specializing in a specific part of the meal preparation, dramatically speeding up the entire process. This parallel processing power significantly accelerates the training of foundational models, reducing training time from months or even years to weeks or days. Furthermore, advancements in GPU technology, such as specialized tensor cores designed specifically for deep learning operations, further enhance their efficiency in handling the massive datasets and complex computations required for these large-scale models. Without the parallel processing capabilities of GPUs, the development and advancement of today's sophisticated foundational models would simply not be feasible. They are the engines that power the current AI revolution. As we've established, training and running foundational models demands substantial GPU resources. However, acquiring and maintaining a powerful GPU infrastructure is often prohibitively expensive for individuals and smaller organizations. This is where cloud-based AI APIs have become a game changer. Leading cloud providers offer access to their vast GPU clusters via APIs, allowing developers to leverage the power of these resources without the significant upfront investment and ongoing maintenance costs. It's similar to renting a high-performance sports car for a day, instead of buying and maintaining one yourself. You get access to the speed and performance without the long-term financial commitment. Cloud AI APIs provide a pay-as-you-go model, making powerful AI capabilities accessible to a wider audience. Developers can now experiment with, fine-tune, and deploy sophisticated models without needing to manage their own hardware infrastructure. This democratization of access has fueled a rapid expansion of AI applications across various industries, empowering startups and individual developers to innovate and compete with larger players. By lowering the barrier to entry, cloud AI APIs have unlocked a world of possibilities, accelerating the development and adoption of AI solutions across the globe. Data privacy and security. While leveraging cloud-based AI APIs offers undeniable advantages in terms of accessibility and cost effectiveness, it also raises critical concerns regarding data privacy and security. When utilizing cloud APIs, you're essentially sending your data to a third-party provider for processing. This raises questions about who has access to your data, how is it being used, and whether it's adequately protected against unauthorized access or breaches. For sensitive data, such as personal health information or financial records, these concerns can be particularly acute. This brings us back to the alternative, hosting open source models locally. By running models on your own infrastructure, you retain complete control over your data, minimizing the risks associated with sharing it with external providers. This is particularly appealing for organizations dealing with highly sensitive data or those operating under the strict regulatory requirements. Furthermore, local hosting can offer performance advantages for certain applications, eliminating the latency associated with sending data back and forth to a remote server. However, hosting open source models locally comes with its own set of challenges. First and foremost, it requires significant upfront investment in hardware, particularly powerful GPUs, as well as the expertise to set up and maintain the necessary infrastructure. This can be a substantial barrier for smaller organizations or individuals. Secondly, ensuring the security of your infrastructure becomes your responsibility. Protecting against cyber attacks and data breaches requires dedicated resources and expertise. Finally, keeping up with the rapid pace of AI advancements and updating your locally hosted models can be a demanding task. Ultimately, the decision of whether to leverage cloud APIs or host open source models locally involves a trade-off between convenience and control, cost and security. Carefully weighing these factors in light of your specific needs and resources is crucial for making informed decisions that align with your priorities and risk tolerance. Choosing the right model. Navigating the landscape of generative AI models can feel overwhelming, given the variety of options available. Choosing the right model for your specific task requires careful consideration of several key factors. First and foremost, define your objective clearly. What are you trying to achieve with generative AI? Are you looking to generate creative text formats like poems or code, realistic images, or perhaps even music? Different models specialize in different domains, so aligning your objective with the model's strengths is crucial. Next, consider the type and quality of the data you have available. Some models are trained on massive general-purpose datasets, while others are specialized for specific domains like medical or legal text. Matching your data to the model's training data can significantly impact performance. If you have a limited dataset, fine-tuning a pre-trained model might be more effective than training a model from scratch. Furthermore, evaluate the model's output quality and controllability. Some models prioritize creative freedom, while others offer finer control over the generated content through parameters and prompts. Depending on your needs, you might prefer a model that produces highly diverse outputs, or one that adheres strictly to specific guidelines. Resource constraints also plays a vital role in model selection. Larger models generally offer better performance but require more computational resources, both for training and inference. Consider your budget, available hardware, and time constraints when making your choice. Finally, explore available APIs and platforms. Different providers offer access to various models with varying levels of customization and support. Experimenting with different options and comparing their performance on your specific task can help you identify the most suitable model. Choosing the right generative AI model is a crucial step in successfully leveraging its power. By carefully considering these factors, you can ensure optimal performance and achieve your desired outcomes. As the field of generative AI continues to rapidly expand, so too does the ecosystem surrounding it. AI model marketplaces and aggregators such as Hugging Face, Eden AI, and Replicate have emerged as central hubs for discovering, accessing, and utilizing a wide range of pre-trained models. These platforms act as a bridge between model developers and end users, simplifying the process of integrating AI capabilities into various applications. Hugging Face. Hugging Face is renowned for its extensive library of open source models and datasets. It provides a collaborative platform for sharing and exploring cutting-edge AI research. It offers tools for easily downloading, fine-tuning, and deploying models, making it a popular choice both for researchers and developers. Eden AI focuses on providing simplified AI endpoints for accessing a diverse collection of AI models from different providers, extracting away from the complexities of integrating with multiple platforms. This allows developers to easily compare and switch between different models, optimizing for performance, cost, or specific features. Replicate specializes in running pre-trained models in the cloud, offering a serverless infrastructure that simplifies deployment and scaling. Users can run models with a simple API call, eliminating the need for managing their own infrastructure. These platforms offer several key advantages. They democratize access to AI, making powerful models readily available to a wider audience. They simplify model development, reducing the technical expertise required to integrate AI capabilities into applications. And they foster collaboration and innovation, enabling developers to build upon existing models and share their own creations with the community. However, relying on these platforms also introduces potential considerations, such as vendor lock-in, data privacy concerns when utilizing cloud-based services, and the need to carefully evaluate the quality and reliability of models sourced from third-party providers. Navigating these trade-offs requires careful consideration of your specific needs and priorities. Nevertheless, AI model marketplaces and aggregators represent a significant step towards making AI more accessible and accelerating its adoption across various industries. With the proliferation of AI models and platforms, the need for objective performance evaluation becomes paramount. This is where AI benchmarks play a crucial role. Benchmarks provide standardized tests and datasets that allow for fair and consistent comparison of different models across various tasks. They serve as a vital tool for researchers, developers, and end users to assess the strengths and weaknesses of different models, track progress in the field, and make informed decisions about which model best suits their needs. The benchmarks typically focus on specific AI domains, such as natural language processing, computer vision, or speech recognition. They often involve tasks like image classification, language translation, question answering, or sentiment analysis. By evaluating models on the same standardized tests, benchmarks provide objective performance metrics, such as accuracy, precision, recall, and F1 score. This quantitative assessment allows for clear comparison of model capabilities and facilitates informed decision making. Furthermore, benchmarks drive innovation by highlighting areas where models struggle, encouraging researchers to develop new techniques and architectures that push the boundaries of AI performance. They serve as a critical component in the ongoing evaluation and advancement of artificial intelligence. A prime example of an organization pushing the boundaries of AI benchmarking is Epoch AI. Unlike traditional benchmark datasets that often remain static, Epoch AI advocates for the creation of living benchmarks that continuously evolve to reflect the rapid advancements in the field. They argue that static benchmarks quickly become outdated, failing to capture the true capabilities of cutting-edge models. Epoch AI emphasizes the importance of evaluating models on tasks that are increasingly challenging and relevant to real-world applications. Their approach involves creating benchmarks that incorporate novel tasks, more complex data distributions, and even adversarial examples designed to test the robustness of AI systems. By constantly raising the bar, Epoch AI aims to drive continuous improvement and ensure that the benchmarks remain a relevant and effective tool for measuring progress in AI. Furthermore, Epoch AI promotes open and collaborative benchmark development, encouraging community involvement in the creation and curation of these critical evaluation tools. Their work highlights the ongoing evolution of AI benchmarking and the importance of adapting evaluation models to keep pace with rapid advancements in the field. This dynamic approach to benchmarking ensures that we have accurate and meaningful measures of AI progress, fostering healthy competition and driving innovation towards more robust and capable AI systems. In complex AI systems, often multiple specialized models work together to address a variety of tasks. Efficiently managing and directing inputs to the appropriate model is crucial for maximizing performance and resource utilization. This is where model routing plays a vital role. Model routing acts as a traffic controller, intelligently directing incoming requests to the most suitable model based on the nature of the input and the desired outcome. This intelligent allocation of tasks leverages the specialized strengths of individual models, ensuring that each request is processed by the most efficient and accurate model for the job. For instance, a request for language translation would be routed to a translation model, while an image classification task would be directed to a computer vision model. This specialization avoids unnecessary processing by general purpose models, saving computational resources and reducing latency. Furthermore, model routing can dynamically adapt to changing workloads and model performance, ensuring optimal resource allocation and maximizing overall system efficiency. Sophisticated routing strategies might consider factors like model accuracy, latency, cost, and available capacity when making routing decisions. By intelligently orchestrating the flow of requests, model routing plays a critical role in optimizing the performance and scalability of complex AI systems. Dynamic routing versus static routing. Let's contrast dynamic routing. Let's contrast dynamic model routing with static routing to better understand their respective applications and benefits. In static routing, the path a request takes is predetermined and fixed. This approach is simple to implement and works well when the characteristics of incoming requests are known in advance and remain relatively consistent. For example, if a system exclusively handles English to French translation, however, static routing lacks flexibility. If a new language pair is introduced, the system will require manual reconfiguration. Dynamic routing, on the other hand, intelligently adapts the characteristics of incoming requests, making decisions in real time. This allows for a more efficient and responsive system. Consider a multilingual translation service with dynamic routing. The system can analyze the input text and identify the language, and automatically route the request to the appropriate translation model. This eliminates the need for predefined rules for each language pair and allows the system to seamlessly handle new languages without manual intervention. Other examples of dynamic routing include sentiment analysis, routing requests to different models based on a detected language or topic; content moderation, selecting models based on the complexity or potential sensitivity of the content; fraud detection, adapted to evolving fraud patterns by routing transactions to specialized models. Dynamic routing excels in scenarios with diverse inputs, evolving requirements, and a need for optimized resource allocation. Its adaptability and efficiency makes it a crucial component in sophisticated AI systems designed to handle complex and dynamic workloads. While static routing has a place in simple, predictable scenarios, dynamic routing offers the flexibility and intelligence necessary for modern AI applications. Introduction to JSON. Now that we've established a foundation in understanding AI models, let's turn our attention to the language they often use to communicate: JSON, or JavaScript Object Notation. JSON is a lightweight data interchange format that plays a crucial role in how AI models receive input and deliver output. Think of it as a universal language that allows different systems, including AI models and applications, to exchange information seamlessly. Its simplicity and reliability make JSON a popular choice for representing structured data. It's based on a key value pair system, similar to a dictionary, where each piece of information is associated with a specific label. For instance, name, John, represents a data point where the key name is associated with the value John. This structured format allows AI models to easily parse and understand the information they receive. Imagine an AI model tasked with processing customer orders. The order details, such as customer name, items purchased, and shipping address, can be neatly packaged in a JSON format, enabling the model to readily extract and utilize this information. Furthermore, JSON's universality ensures compatibility across various programming languages and platforms, whether you're working with Python, JavaScript, or any other language. Whether you're working with Python, JavaScript, or any other language, you can easily process and generate JSON data, making it an ideal choice for integrating AI models into diverse applications. Its lightweight nature also contributes to efficient data transmission, minimizing overhead and improving performance. In essence, JSON serves as a critical bridge between human-readable information and machine-readable data, facilitating seamless communication between AI models and the wider world of applications and systems. Understanding JSON is fundamental to working effectively with AI models and integrating them into your projects. Understanding how computers communicate. Building upon the concept of JSON as a language for data exchange, let's explore how computers utilize this language to communicate with each other, specifically through web APIs, application programming interfaces. APIs define the rules and methods for different software systems to interact and exchange information. Think of an API as a waiter in a restaurant. It takes your order, the request, relays it to the kitchen, the AI model or another system, and brings back the food, the response. JSON often acts as the language in which these orders and responses are written. When computers communicate via APIs, they often use the standard HTTP methods to specify the type of action they want to perform. 4 common methods are GET. This retrieves data from the server, like asking the waiter for the menu. POST. This sends data to the server to create a new resource, like placing an order. PUT. This updates existing data on the server, like asking the waiter to modify an existing order. Delete. Delete removes a resource from the server, like cancelling an order. These requests often utilize JSON to structure the data being sent or received. For instance, a POST request to create a new user might include a JSON payload with the user's name, email, and password. The server will then process this JSON data and send back a response. The server will then process the JSON data and send back a response, often also in JSON format, indicating success or failure. This standardized framework, combining HTTP methods and JSON for data representation, enables seamless communication and interaction between different software systems, making it a cornerstone of modern web development and AI integration. JSON and Cloud AI API providers. This mechanism of using HTTP methods and JSON for communication forms the foundation of how we interact with cloud-based AI API providers. These providers encapsulate complex AI models behind well-defined APIs, allowing developers to access powerful AI capabilities without managing the underlying infrastructure. By utilizing standard HTTP requests and JSON payloads, developers can seamlessly integrate these AI services in their applications. For instance, to perform sentiment analysis on a piece of text, a developer might send a POST request to a sentiment analysis API endpoint, including the text within a JSON payload. The API will then process the text using its underlying AI model and return a JSON response containing the sentiment score. This streamlined process abstracts away the complexities of model training, deployment, and scaling, enabling developers to focus on building their applications. This approach allows for rapid prototyping and development, enabling developers to quickly test and iterate on AI-powered features. Furthermore, it provides access to cutting-edge AI models and infrastructure without significant upfront investment. Cloud AI API providers handle the complexities of managing and scaling the necessary resources, allowing developers to focus on the core competencies, building innovative and impactful applications. By leveraging these APIs and adhering to established communication protocols, developers can seamlessly integrate powerful AI capabilities into their projects, unlocking a world of possibilities for innovation. JSON examples. Let's illustrate how JSON is used in OpenAI API requests with a concrete example. Imagine you want to use the OpenAI API to generate text using the GPT-4o model. Your goal is to have the model complete the following sentence. The quick brown fox jumps over the lazy. The body of this request would contain a JSON object specifying the necessary parameters for the text generation task. Here's an example of what the JSON payload might look like. In this JSON object, model specifies the desired GPT-4 model variant. Prompt provides the input text for the model to complete. Max tokens limits the length of the generated text. Temperature and top P control the creativity and diversity of the output. N determines how many different completions the model should generate. Stop defines optional stopping conditions for text generation. Upon receiving the request, the OpenAI API would process it using the specified GPT-4o model and return a JSON response containing the generated text completion. This response would also include other relevant information, such as the number of tokens used and any potential errors incurred. This example demonstrates how JSON provides structured and unstructured way to communicate with the OpenAI API, enabling developers to specify the desired task and parameters and receive the results in a well-defined format. Understanding this JSON structure is fundamental for effectively utilizing the OpenAI API and harnessing the power of its AI models. Let's reiterate two key concepts crucial for understanding how to interact with APIs: endpoints and key value pairs. Endpoints are essentially the specific URLs you use to communicate with different parts of an API. Think of them as the different departments within a company, each responsible for a specific function. For instance, an API might have separate endpoints for creating a new user, retrieving user information, processing payments, performing sentiment analysis. Each endpoint corresponds to a specific resource or action within the API. Knowing the correct endpoint to use is essential for directing your request to the appropriate functionality. Now let's look at key value pairs. Key value pairs are the fundamental building blocks of data representation in many formats, including JSON, which is commonly used in API communication. As the name suggests, a key value pair consists of a key, which acts as a label or identifier, and a value, which represents the data associated with that key. In the context of API requests, key value pairs are used to structure the data being sent to and received from the API. Within a JSON object, the key value pairs are enclosed in curly braces and separated by commas. The keys are closed in double quotation marks, and the values can be various types of data, such as strings, numbers, booleans, or even nested JSON objects. For example, in the previous OpenAI API request example, model text DaVinci 003 is a key value pair where model is the key and text DaVinci 003 is the value. Understanding both endpoints and key value pairs is crucial for effectively interacting with APIs. Endpoints direct your requests to the correct functionality, while key value pairs provide a structured way to represent and exchange data with the API. Mastering these concepts will significantly enhance your ability to utilize APIs and unlock the power of the services that they offer. What are tokens? Now, let's explore a crucial concept that underpins many cloud AI APIs, especially those dealing with text: tokens. Tokens are the fundamental building blocks of text as understood by AI models. They can represent individual words, subwords, or even characters, depending on the specific tokenization method used. Think of them as discrete units that AI models use to process and understand language. This process of breaking down text into tokens is essential for AI models to perform tasks like language translation, sentiment analysis, and text generation. These models operate on numerical representations of data, and tokens provide a way to convert text into a format that these models can understand. Each unique token is assigned a numerical identifier, allowing the model to process and manipulate text as numerical data. Many providers charge based on the number of tokens processed in a request. This model pricing reflects the computational resources required to process and analyze text. Longer texts, which require more tokens, incur higher costs. Understanding how tokenization works and how it impacts pricing is crucial for effectively managing costs when using cloud AI APIs. By optimizing your text inputs and minimizing unnecessary tokens, you can ensure efficient utilization of these services and control your expenses. This awareness of tokenization not only enhances your understanding of AI processing, but also empowers you to make informed decisions about utilizing cloud AI resources. Token limits and context windows. Building on the concept of tokens, it's important to understand that AI models often have limitations in the amount of text they can process at once. This limitation is typically defined by token limits and context windows. A token limit refers to the maximum number of tokens a model can handle in a single input. This constraint stems from the computational resources required to process and analyze text data. Think of it as the model's working memory capacity. The context window closely relates to the token limit, but refers to the specific portion of the text that the model considers when generating a response or making a prediction. It's like the model's field of vision, focusing on a specific segment of text while potentially ignoring information outside that window. The size of the context windows varies depending on the model architecture and available resources. Some models might have a relatively small context window, focusing on only a few sentences at a time, while others boast large windows capable of considering entire paragraphs or even longer documents. These limitations have practical implications for how you interact with AI APIs. Exceeding the token limit will result in errors. Furthermore, understanding the context window is crucial for crafting effective prompts and ensuring that the model has access to the necessary information to generate accurate and relevant responses. Strategies like breaking down long text into smaller chunks, or carefully structuring prompts to include essential information within the context window are crucial for maximizing the effectiveness of AI models. By understanding these limitations and adapting your approach accordingly, you can ensure optimal performance and avoid unexpected results when working with AI APIs. While cloud AI API providers strive to make their services accessible to a broad audience, understanding how to navigate developer documentation is often essential for effective utilization, even for non-technical users. This is akin to learning to read a map before you embark on a journey. While you might not need to be a cartographer, understanding basic map symbols and conventions is crucial for reaching your destination. Model providers typically invest heavily in creating comprehensive documentation that outlines available services, a catalog of AI models and functionalities, offers such as language translation, sentiment analysis, image generation, etc. This helps you identify the right tools for your specific needs. API endpoints. These are specific web addresses you can use to interact with the AI models. Understanding how to structure API requests, including specifying the desired model and input data, is crucial for successful integration. Authentication and authorization. This section details how to securely access the API using API keys or other authentication methods. This ensures that only authorized users can utilize the services. Request and response formats. This crucial part of the documentation explains how to format your input data, often used in JSON, and how to interpret the model's output. Understanding the structure of the response allows you to extract the relevant information. Code examples. Most providers include code snippets in various programming languages, Python, JavaScript, etc., to demonstrate how to make API calls and process the responses. These examples serve as practical guides for integrating the API into your applications. Error handling. This section outlines potential errors that might occur during API interactions and provides guidance on troubleshooting and resolving these issues. Pricing and usage limits. Understanding the pricing structure and any limitations on usage, such as the number of requests or tokens allowed, is crucial for managing costs and avoiding unexpected charges. Even without deep technical expertise, familiarizing yourself with these key elements of developer documentation empowers you to effectively leverage cloud AI APIs. Start by focusing on the sections most relevant to your immediate needs, using code examples as starting points, and gradually expand your understanding as you gain experience. Just as learning to read the map unlocks the ability to explore new territories, understanding developer documentation opens up a world of possibilities for utilizing the power of AI in your projects. Exploring OpenAI's playground. We've covered a lot of ground, laying a solid foundation in AI concepts, from foundation models to the intricacies of tokens and API communication. Now, it's time to put that knowledge in action through hands-on exploration in the OpenAI developer playground. This interactive environment provides a sandbox for experimenting with OpenAI's powerful AI models without the need for complex coding. The playground is a virtual laboratory where you can test different prompts, tweak model parameters, and witness the AI's response in real time. You'll learn how to craft effective prompts that elicit desired outputs, fine-tuning your instructions to guide the model's behavior. Experimenting with parameters like temperature and top P will allow you to control the randomness and the creativity of the generated text, exploring the spectrum from highly focused and deterministic to more imaginative and unpredictable. The playground also offers the opportunity to compare and contrast various OpenAI models, gaining a deeper understanding of their individual strengths and weaknesses. You can test different models on the same task and observe how their outputs vary, providing valuable insights into which model best suits your specific needs. Furthermore, you will gain practical experience in interpreting the API responses, deciphering the JSON output, and extracting the relevant information. This hands-on experience in the OpenAI playground will solidify your understanding of core concepts and empower you to confidently utilize OpenAI's API in the real-world applications. By actively experimenting and exploring, you'll bridge the gap between theory and practice, transforming your newfound knowledge into tangible skills for leveraging the power of AI. It's time to get started, get your hands dirty, and unlock the power of OpenAI's incredible AI models.